When it comes to choosing the right storage device for your computer, the options can feel overwhelming. SSD, HDD, NVMe, SATA, mSATA, and M.2. What do all these terms mean, and how do they affect your device's performance? Let's cut through the confusion and break it all down, so you know exactly what you're working with. Since it relies on physical movement to function, it's inherently slower than solid-state technologies. Boot times, file transfers, and loading applications will take noticeably longer on an HDD compared to newer solutions. First, let's start with the most basic and traditional storage type, the hard disk drive, or HDD. This is the mechanical storage we've used for decades. Functionally, it performs the same as a regular SATA SSD, just in a more compact form factor. While mSATA was revolutionary at the time, it's largely being phased out in favor of newer standards like M.2. Inside an HDD, there's a spinning magnetic disk, and a needle reads and writes data as the disk spins. It's similar to how a record player works. M.2 drives are slim, flat sticks that plug directly into the motherboard. It can be either SATA or NVMe, which is where confusion often sets in. NVMe SSDs are blisteringly fast, talking read-write speeds that can reach several thousand megabytes per second. This is perfect for tasks that demand rapid data access, such as 4K video editing, large-scale data processing, or high-end gaming. With NVMe, you can dramatically reduce load times and boost responsiveness. Just because something is M.2 doesn't automatically mean it's faster. If an M.2 drive uses the SATA protocol, it will still have the same speed limitations as a regular SATA. Many users pair a smaller NVMe SSD for their operating system and applications, and a larger HDD for bulk file storage. But understanding these different storage options gives you the power to make informed decisions when building or upgrading your computer. So next time you see those acronyms HDD, SSD, NVMe, SATA, mSATA, or M.2, you'll know exactly what they mean and how they affect your system's speed and performance. That way, you get the best of both worlds, speed and space. It's been around since the early 2000s. SATA SSDs still offer a major speed boost over HDDs, but they're limited by the maximum bandwidth of the SATA interface around 600 megabytes per second. For most everyday users, that's still more than fast enough, especially for tasks like web browsing, working with documents, or casual gaming. Unlike HDDs, SSDs have no moving parts. Instead, they use flash memory to store data. This means they're faster, more durable, and quieter. SSDs have revolutionized how quickly systems can boot, open files, and run programs. Even a basic SSD can offer performance that completely outpaces an HDD. HDDs are known for offering large storage capacities at a lower cost. You can get multiple terabytes of space for a relatively small amount of money. If you want maximum storage at the lowest price and don't care much about speed, an HDD works fine. If you want your system to feel snappy and fast, even a basic SATA SSD will make a world of difference. But if performance is critical and your motherboard supports it, an NVMe M.2 drive is the way to go. However, speed is not an HDD's strong suit. That brings us to solid-state drives, or SSDs, but not all SSDs are created equal. This is where interfaces and form factors come into play. SATA, NVMe, mSATA, and M.2. These are not types of drives themselves. They are ways the drives connect to your computer and impact speed. STA, or serial ATA, is the most common interface for both HDDs and older SSDs. Then there's mSATA, or mini SATA. This is a smaller version of the SATA interface, designed for compact devices like laptops and mini PCs. Now let's talk about M.2, a form factor, not a performance standard. But when an M.2 drive uses the NVMe protocol, that's when things get interesting. NVMe, or Non-Volatile Memory Express, is a protocol designed specifically for SSDs to fully exploit the high-speed PCIe interface. So how do these all stack up? HDDs are cheap, spacious, but slow. SATAs are faster and more reliable, but capped by interface limits. mSATA is a compact version of SATA, mostly outdated. M.2 is a form factor that can support both SATA and NVMe, NVMe over M.2 or PCIe is the fastest option available today. When choosing storage, it comes down to your needs. It's also worth mentioning that you don't have to pick just one. As technology evolves, SSDs will only get faster and more affordable, making HDDs less relevant for most consumers. We appreciate you for watching. Please like and subscribe to our channel. Cheers.